Right, this is Year 12 Pure Maths, Chapter 13, Lesson 1. Today we're going to be learning about the basics of integration, how do you deal with integration and indefinite integration. We're not going to be going into kind of all the hows and the kind of whys of it, really deep information with integration. It's going to be very superficial today, so we're just going to learn how to use it. Okay, let's get cracking. So the first thing that I'd expect you to be able to do is to differentiate each of these things. Now, I would suggest pausing the video and giving this a go. Differentiate each of these. I'll give you a chance to pause it now. Okay, so if you did differentiate, you should have got the following things. So dy by dx would be equal to 4x, and that's it. Okay, bring down the power, take one off the power. So bring down the power, take one off the power, and the constant, well, that's an x to the 0, isn't it? And so it just disappears. Dy by dx here would be bring down the power, take one off the power. So you should notice something there. We'll talk about that in a minute. That's really important, what we need to notice. Next, if we've got f of x, then the derivative is f dash of x, and that'll be 15x to the power of 4. And if we've got f of x being this horrible looking thing here, bring down the power, take one off the power. Okay, we end up with that. So there is just some simple differentiation, which you should really be able to do before you start trying to learn about integration. If you can't do this, look back in your books. The important thing to notice is that where we've differentiated and we had a constant term, that constant term disappears. And so here, if I only told you this information here, you would be able to tell me that the original function had 2x squared, but you wouldn't be able to tell me the constant part of the original function. You wouldn't be able to tell me that. That's a mystery. But you would be able to tell me this. Okay, you could work backwards to figure that out. And if you think about how we could work backwards, we could, well, if we were previously bringing down the power to multiply and then adding and then subtracting 1 from the power, well, we could add 1 to the power, so we get 4x squared, and then divide by the new power, and what you get is 2x squared. So we could get back, couldn't we? And that would be fine. So we could get 2x squared. Fine. Now, that operation that I've just done there is really important. We'll talk about why in just a second. But here what you can see, let's figure out whether the same thing happens. We said you could add 1 to the power to get back, so you get to 5, and you could divide by the new power. And 15 divided by 5 is 3. So we know that something special happens with add 1 to the power, then divide by the new power. And let's just double check, does this work? If we add 1 to n minus 1, we get n minus 1 plus 1 is n. And then we divide n by n, and we just get back to x to the power of n. This is great. Now this here, this rule is called integrating. Oops. Integrating. And that needs to be written in your book. It needs to be ready to go. Add 1 to the power, divide by the new power. It's the opposite of differentiation. Integration is the opposite of differentiation. You'll learn in the next couple of lessons about what it is and why it's doing that, and you know what it actually calculates. But for now, it's just going to be an operation. We add 1 to the power, divide by the new power, and we'll just get used to using it today. So let's crack on, shall we? So given that dy by dx is 3x to the power of 5 plus 2x, find the value of y. So we know that there's some function that has been differentiated to create 3x to the power of 5 plus 2x. We know it's been differentiated. And that original function will have had higher powers than we've got there. It won't have a power of 5, it'll have a power of 6. Okay, so when we differentiate, we take 1 off. But it could have also had a constant on it. Okay, now look back onto these here, where we had the constants, they just disappeared. So keep that in the back of your mind just while we work on this next question. So to undo a differentiation, we integrate. We said that they're the opposites of each other, and so we're going to integrate. Add 1 to the power, divide by the new power. Plus, add 1 to the power, divide by the new power. But if we said this way is to differentiate, then this way would be to integrate. And we don't know whether there would have been a constant. So what we need to do with this type of integration is put plus c. There could have been a constant. We don't know. We haven't got a clue. In the next lesson, you'll be able to find out what some of those constants are, and it involves you being given some extra bits of information. But for now, we're just going to leave it as plus c. And whenever you do this type of integration, which is called indefinite integration, you'll be putting plus c on there. Okay, so y would have been something x to the power of 6 over 2 plus x squared plus something. Okay, we don't know what that something would have been, but it would have to have been a constant. C cannot be anything other than a constant. It can't be like a 2x or a 3x or something like that. All right, next up, we've got given that dy by dx equals this thing. So I'll give you a hint because you might want to work ahead on this. Turn everything into power form and expand it first. You might find the fractions a little bit tricky, but realistically it just takes a little bit of practice. So you might want to pause the video and work ahead. Okay, so first off, dy by dx will equal 3x to the power of 1/2 plus 2x squared plus 3x. And so therefore y will equal to, well, add 1 to the power and divide by the new power. Next, 2x squared, add 1 to the power, divide by the new power. Next, add 1 to the power, divide by the new power, and probably plus c on there. Now this term can't simplify, nor can this, but this can. And sometimes people find it a little bit awkward to deal with, to have kind of this 3x to the power of 3 over 2 over a fraction. People find that a little bit awkward. A good rule is if you're really not sure what to do, you could just do 3 divided by 3 over 2 in your calculator if you really want to. What actually happens is that the 2 is going to multiply by the 3, and so you get 6 over 3, which is 2. So you'll get 2x to the power of 3 over 2 plus 2x cubed all over 3 plus 3x squared all over 2 plus c. Okay, hopefully you managed to beat me to it. If you did, well done. Okay. On this question, we've got something that looks ever so fancy. It's got this big, massive S-looking thing. Okay, that is called an integrand, and it indicates that you're going to be doing some integration. That's all it is. It basically is saying integrate all this stuff with respect to x. Okay, well, you don't know how to do anything else. If it says a load of t's in here and it says dt, that's fine, but you don't know how to do anything else with like a different letter here versus a different letter here at the moment. So this basically just says integrate as you would expect. So we're going to integrate this. Now, the first thing to do is to get everything into power form. So we're going to have x to the power of 1/2 over 3 plus 2x to the power of 3 over 3 with respect to x. And it's a good idea to split this out, divide it into 2 separate fractions if you can. Okay, now we're going to integrate, and so what we'll get will be add 1 to the power, divide by the new power, so we'll have over 3 lots of 3 over 2 plus add 1 to the power, divide by the new power, plus c. Okay, again, sometimes people find these things really confusing. Here what we'll get is going to be x to the power of 3 over 2 over 9 over 2 plus 2x to the power of 4 over 12 plus c, which will be 2/9 x to the power of 3 over 2 plus x to the power of 4 all over 6 plus c. Now you'll note that the awkward part here was dealing with this third here. It sort of made things really awkward. So what I'm going to show you is that this can be done a little bit easier. If you have a constant running through that can be factored out, so in this case each of these terms is being multiplied by 1/3, if it could be factored out and it's a constant, you could actually just do this. You could integrate with that constant already factored and then multiply it back in, so you can deal with that. Now, sometimes people find that a bit easier to deal with, So you would have 1/3 of the integral of x to the power of 1/2 plus 2x cubed dx, and that's going to be 1/3 of x to the power of 3 over 2 over 3 over 2 plus 2x to the power of 4 all over 4 with respect to x, which will be 1/3 lots of 2/3 x to the power of 3 over 2 plus x to the power of 4 over 2. You don't need this dx here, sorry, I didn't need that. And so we'll get 2/9 x to the power of 3 over 2 plus, should have been putting plus c there as well, oops, plus c plus x to the power of 4 over 6 with a plus c on the end. Okay, and so you get the exact same thing. So if you've got a constant that can be factored out from each of the terms, then feel free to do it. It can make things a little bit easier. In some cases, well, most cases, it will already make things easier. All right, so your task is in the active book on exercise 13b, questions 4, 5 and 8. Make sure you get things into power form and expand them before you start trying to integrate. Remember, the rule is pretty simple: add 1 to the power, divide by the new power. The most difficult thing at this point is probably going to be dealing with fractions, especially those fractions that turn up in the denominators. Good luck.